Welcome back to Basic Biostatistics 2, to Session 5, ANOVA analysis. And in this last video, I'm going to give you a short introduction into repeated measures ANOVA. As you remember from the previous chapter, if you had a before-after measurement, two measurements, we can use repeated measures t-test. However, if you have 3 or more time points where I've measured the same value in the same subjects, we cannot use repeated measures t-test, but we need to use repeated measures ANOVA. That is for differences in a certain continuous variables among 3 or more time points. In a practical example, we would like to know whether diastolic blood pressure of month 1, 2, and 3 are statistically significant different. In case they're different, we would like to know whether there was a difference in diastolic blood pressure between month 1 and 2, between month 1 and 3, and month 2 and 3. This we can do in SPSS under repeated measures ANOVA. We go to Analyze, and here under General Linear Model, GLMs sometimes called, we go to repeated measures. The first thing in our analysis, our outcome variable is diastolic blood pressure. We have measured it at 3 different time points. So the within subject factor name is the time points or time. So we're going to write in this window time, means labeling our independent variable. Time consists of 3 different measurements. We have diastolic blood pressure measured in month 1, 2, and 3. Therefore, the number of levels is 3. If you would have measurements as well in month 4 and 5, the number of levels will be 5. Before you continue, you have to click on Add. Now SPSS knows that we have measured diastolic blood pressure in 3 different times. The next we have to do is click on Define. It's basically the only button we can press to continue. And then we have a new window that opens, and here we define all the different variables. You see, as usual, here on the left-hand side are continuous variables. You see on the right-hand side the within subject variables, and these are 3 different time points. Now I've defined what was actually measured in 3 different time points. As we know that the first time point was diastolic blood pressure month 1, the second was month 2, and the third was month 3. So I simply select first diastolic blood pressure month 1, I move it into the window on the right-hand side. Then I select diastolic blood pressure month 2. I move it on the window on the right hand side, and I select diastolic blood pressure month 3 and as well move it to the window. As you can see now, we have defined the 3 different measurements, diastolic blood pressure 1, 2, and 3. The only thing that's left to do in this stage, if you have a simple comparison of the 3 different measurements, we go to Options. Here we'd like to have the means displayed for the 3 different measurements. I click on time, move it to display means for. This means that we're going to receive the mean values for diastolic blood pressure of each of the month. I click on compare main effects, as we're interested in pairwise comparisons. We would like to know whether there was a statistical significant difference of month 1 and 2, between month 1 and 3, and between month 2 and 3. And the LSD test is one of the tests that gives us pairwise comparisons. I'm also interested in descriptive statistics, so I click on descriptive statistics. Click on OK, continues, and then OK, and we have the output window of our test. Now, next I show you which of these windows, because you have a lot of information in the output window, are important to interpret. First of all, you see here, this tells us that we have 3 time points and what are dependent variables of our time points. Diastolic blood pressure month 1, 2, and 3. The second table gives us descriptive statistics. It tells us that the mean value of diastolic blood pressure month 1 was 97.97, of month 2 was 95.93, and of month 3 was 91.93. So looking at that, we can probably assume there seemed to be a linear decrease in diastolic blood pressure within the 3 months. However, we don't know yet if this difference is statistically significant, and whether the difference is significant between all the 3 measurements. We also have a standard deviation of each of the mean values, and we have the number of subjects with the valid measurement, that is 60. Now the next table, basic multivariate test, you can omit. This is only valid for huge sample size where I have thousands of subjects. In that case, the Wilks lambda test result will tell us whether there are differences in diastolic blood pressure among the three groups. However, as our data set is small, you can omit the interpretation of that table. In repeated measures ANOVA, there's one assumption. The assumption is that there's sphericity among the differences of each pair of comparison. What does this mean? This means that we first will calculate the mean difference in diastolic blood pressure between month 1 and 2, which is 2.04, and calculate the variance. This will give us a variance for the first pairwise comparison between month 1 and 2. We would also calculate the mean difference between month 1 and month 3, that is more or less 6.04. And we also will calculate the variance for that difference. This gives us a second variance. And the third one will be the difference between month 2 and month 3, which is exactly 4. We'd calculate the variance for that difference, so we'd receive 3 different variances. Now, sphericity assumed means that these 3 variances are the same. There's no differences between the 3 variances. This is very rarely the case. In repeated measures ANOVA, we almost always violate the assumption of sphericity or equality of variances. In order to know whether we violate the assumption, we have a Mauchly's test of sphericity. This test, if it's statistically significant, means that the variances are different after 3 different differences. In our case, we see that for the variable time, the test value is so small that the statistical significance is so small that we do not get a p-value for that test. This means that we can assume there's no sphericity, or the variances of the 3 different differences are different. How do we use this information provided in the sphericity test? We go to the next table, and this table tells us whether the difference in diastolic blood pressure between the 3 months was statistically significant. In case we would have sphericity, we would interpret the first line of the results. However, in our case, sphericity is not assumed, so we interpret the results of the Greenhouse-Geiser test. And we see that p-value is less than 0.05. This means that we reject the null hypothesis, so we know that the 3 different diastolic blood pressure measurements are statistically significantly different. Some people say that you can never assume sphericity in repeated measures ANOVA, so you should directly interpret the Greenhouse-Geiser test. The other tests here, like the Hohenfeld test, the lower bound, there are other corrections for the same matter if sphericity is not assumed. But the most popular test is the Greenhouse-Geiser test. Good, as we still don't know which of the differences are statistically significant, we scroll down until we go to the pairwise comparison test. On this basic table, you already know how to interpret. This gives us the pairwise comparisons. It compares whether statistical significant difference between month 1 and 2. We see the p-value below 0.05, so it's different, and between month 1 and 3, which is also statistically significant. Between month 2 and 3, the value is so small, we have no standard errors, it's exactly 4, so we can consider this as statistically significant as well. So we have statistically significant differences in diastolic blood pressure between month 1 and 2, between month 1 and 3, and between month 2 and 3. This is everything you need to know about a simple repeated measures ANOVA. Now, I'm going to explain you one additional information that may be useful for your statistical analysis. Sometimes we can maybe assume that the difference in diastolic blood pressure, maybe there's an interaction with BMI, meaning that in some of the BMI subgroups there was a decrease in diastolic blood pressure, and in other groups maybe an increase, similar than to multi-way ANOVA. In order to assess or check for that, we go back to Analyze, to General Linear Models, Repeated Measures ANOVA. In this example, we already defined the 3 time points, so we click on Define, and we still have our measurement of diastolic blood pressure. To know whether this is difference or valid, the difference according BMI categories, I select BMI categories and move it into Between Subjects Factor list. In that case, I go to Plots, and I would like to have separate plots for BMI category And the information I'm interested in is in diastolic blood pressure. So I choose time as a horizontal axis. I need to click on add to add it to the window and click on continue. Now click on OK and we have a new output window. The first table again, we have 3 different diastolic blood pressure measurements, 3 different times, but we have as a between subject factors, we have the 3 BMI categories. We have 17 people in their normal weight, 29 obese, overweight, and 14 obese. We have now descriptive statistics for each of the 3 blood pressure measurements according to BMI category. Here, for this is in month 1, diastolic blood pressure was in the normal weight was 97.76, in the overweight 98.41, and in the obese 97.29. And we have the same information for each of the 3 blood pressure measurement month. Again, multivariate test only valid for huge sample sizes omitted. The sphericity test, the multi-test sphericity, again, we cannot assume sphericity. The p-value is so small it could not be calculated. And then we check basically the table with the test of within subject effects. The first one is for a variable time, and we interpret the greenhouse geyser. The null hypothesis is that there's no statistical significant difference in the 3 measurements. Our p-value, as you already know, is below 0.05. This means we have a statistical significant difference in the 3 measurements of diastolic blood pressure. Now, the next column, the next row tells us whether there's an interaction between time and BMI categories, or whether this difference or the direction of difference is the same according in all BMI categories. The greenhouse geyser test is bigger than 0.05, it's exactly 0.594. This means we accept the null hypothesis, and we state that these differences or attendance is the same according all BMI category. If this test will be statistically significant, that means that the differences between the diastolic blood pressure measurements depends on the category of BMI therein. So it will be different for normal weight, will be different from overweight, and different for obese dwarfs. Then we scroll down until we get to the pairwise comparison tests. Here exactly the same. We would interpret whether there's statistical significant difference between month 1 and 2, month 1 and 3, and month 2 and 3. And as you already know, all these differences of pairwise comparisons are statistically significant, so we can assume that the diastolic blood pressure differs between each of the 3 measurements for all pairwise comparison. And in the end, we see our profile plots. We see these profile plots are parallel, so it also shows you in a graphical way that there's in all 3 BMI categories, there's a similar tendency that over time, diastolic blood pressure decreased between month 1 and 2 and between month 2 and 3, almost parallel, so no interaction. If these lines would be in opposite direction, they would clearly cross. This would mean there's interaction and that there are differences, and the differences between diastolic blood pressure depends on BMI category. This was a very short introduction to repeated measures on ANOVA. To go more details about repeated measures on ANOVA, this will not be within the scope of this basic biostatistics course. However, if you're interested, I'm on long-term basis, I'm planning on I have a basic biostatistics 3 course where I'm going to explain in more details, in more depth, repeated measures on ANOVA. Thank you very much. I wish you good luck in the quiz and in the exercises. See you in session 6.